This presentation covers Chapter 3, Section 7 on enumerated types. Enumerated types are a powerful programming tool that I would like you to become comfortable with as soon as possible. Enumerated types allow the programmer to specify the acceptable range of values for a new type that they create. We set the established values for a particular type. Java allows you to define an enumerated type, which can then be used to declare variables. The only allowable values are identifiers of your own choosing. A few sample declarations that create enumerated types. We see the enumerated type season, coin face, and the definition for enumerated type card suit. Enumerated types offer a clean, clear way of programming about well-understood, definable, real-world concepts. Enums are incredibly useful and will help make our programming code more secure and readable. For example, when we flip our coin, its face will be either heads or tails. There is no clearer way in code to describe that coin flip action. Let's look at how we define, declare, and use the enumerated types. Here are two examples from the previous slide that might be very useful in code. The first one is the enumerated type for season of the year, and the valid range of values that the programmer defines are winter, spring, summer, and fall. The second example shows the use of enumerated types for the suits of a deck of cards: clubs, diamonds, hearts, or spades. The declaration of enumerated type variables is straightforward. Use the enumerated type and an identifier name for the variable. Then we can assign the variables a value from the range we provided in the enumerated declaration. Variable time of year can be set to either season, winter, spring, summer, or fall. Variable suit can be set to either clubs or diamonds or hearts or spades. Notice that the type .value is used to set the value for the variable. We can use them in switch statements or if statements too. It is such a terrific way to make our programs more understandable when we can explicitly identify the card suit when playing card games. And the enumerated type enforces that the code only use the allowable types defined in the enumerated type list. This reduces the amount of type checking that needs to be coded. It's all managed by the compiler. Under the hood, the enumerated type is a special type of class, and each allowable value is actually a constant object of the class. In addition to the name values, Java stores an ordinal value, the numbered position in the list of values for each one. Note that Java starts counting from 0, so the first name value has an ordinal of 0. Although some languages allow the programmer to specify the ordinal values, Java does not allow it. We cannot assign or change these ordinal values. They are set in stone by the Java compiler. The name method returns the name of the identifier corresponding to the object's value. Although Java provides us with the name and ordinal properties, most of the time, say 99% of the time, we will be using just the value of the enumerated type variable. We can even display their value directly by using the variable name inside a system.out print line. Look at the example on the screen. System.out.println time of year. The output from this would be fall. Listing 3.6 demonstrates the definition, declaration, and assignment for an enumerated type for ice cream flavors. The enumerated type flavor has 8 available flavors listed. Now, if this were Baskin & Robin, we would have to put a lot more options up there. And we could, because there really is no limit to the number of values we put in our enumerated type. Next, we see the declaration for 3 flavor variables, cone 1, cone 2, and cone 3. Then we assign cone 1 flavor.rocky road and cone 2 flavor chocolate. The system.out print lines show us the stored value, ordinal, and name for cone 1, and on the next page we see the system out print lines for cone 2. Then we assign cone 3 to be the value of cone 1. So we now have 2 Rocky Road fans. Lastly, we check for truthiness. Is cone 2's stored value equivalent to chocolate? If so, we generate the happy observation that chocolate is not just for breakfast anymore. Now I put the output on the screen so that we could compare the lines of code to the output they generated. You should be able to match up the lines of code to the output. I hope this encourages you to start incorporating enumerated types into your programs. It is a tool that I use frequently, and I certainly appreciate how it makes programs easier to read and understand while adding a level of type checking security to programs that improves their reliability. Happy coding!